I think I'll just start lah. Oh, so the how rules, just read through. We'll just give a brief recap. Turn on your cam and mute your microphone. Message which we have been doing so far. Urgent, you need to go to the toilet, or something crop up in the last minute, just raise your hand. Yeah, respectful. Basically, don't post funny things and all that. All right, okay. Come, let's look at the lesson properly. Yeah. Okay. Well, today we'll be doing worksheet 2, physical quantities, units, and measurement. So you have not watched the lesson yet, go back to lesson 1 and 2. All right. The worksheet questions, I don't believe you have done so, so I'll do a bit slower. So if you have anything, you just raise out any things you're not sure. Okay. Don't need to go slow. Okay. Okay, what you will learn, what is quantities. One more person coming. Okay, Yu Yuan, we are just about to start the lesson. So I believe you joined us also last lesson. Yeah, so let's go through this. Okay, let's look at question 1. Yeah. Which instruments are most suitable for the accurate measurement of the thickness of a coin and the internal diameter of a test tube? So let's look at coin first. Coin is a very small object, right? So the thickness will use a micrometer. Your textbook or your school notes will put micrometer, a digital micrometer. Test tube, cups, things, small things that are round. We want to find the diameter. We'll use a vernier caliper. So yes, you're right. Next, the measurement of a block of wood is measured as 120 mm, 5.0 mm, and 3.2 mm. Which of the following measuring are used to measure the readings? So 120 mm, 2 and 3 are micrometer and no micrometer in this case. Why? Because for micrometer, if it's 3.2 mm, they have to write it as 3.20 mm. Even if it's just 3.2. Okay? Vernier caliper, they have to write it as 3.2 mm, they'll write it as 0.32 cm. So vernier caliper, 2 decimal place of a cm. Micrometer will be 2 decimal place of a mm. Clear? So in this case, there's no micrometer. We can basically cancel away B, C, D, and choose A. Understand? Now, 120, if I change it to cm, it will look like 0.12 meters, which is at 12.0 cm. In case you all forget, 1 cm is equals to 10 mm. This is important. So in previous chapter, we learned how to change from all this cm to mm, cm to meters, meters to cm, meters to mm, and so on and so forth. Okay, let's look at the next question. So we must look at what? Now everything's in cm already, but micrometer gives me let's say it's like that. 3.22 mm. It will become. So if it's 3 decimal place of a cm, I know that that reading has to come from micrometer. Vernier caliper, 2 decimal place of a cm. Therefore, answer is C. Okay, next. Now this is pendulum. Pendulum, there are certain words that they will use. For example, this round thing is not called a ball, it's called a ball, by the person's name. This is the length of a string. If the period of, so first of all, what is a period of a pendulum? With respect to this question, it will be from using P as a starting point, P to Q, Q to R, R to Q, back to P. That's one complete oscillation. Consists of 4 quarters. So let's say if go from P to R, then back to P again, it's 2 seconds. So from P to Q will be 1/4 of 2 seconds will be 0.5 seconds, 0.5 seconds, 0.5 seconds, 0.5 seconds. So Q to R will just be 0.5 seconds. Answer is A. What is the difference between period and oscillation? One complete oscillation is what I just described. P to R, back to P. The time taken for it is called 1 period. Okay, so if I put it in simple terms, period is time taken for 1 complete oscillation. Yeah. Next. The bob of simple pendulation is swinging between X and Y. It takes 9.4 seconds to swing from X to Y and back to X 20 times. So how many complete oscillations are there? 20 complete oscillations. And how long it takes me? 9.4 seconds. So one complete oscillation will take how long? Is it? You take 9.4 divided by 20, yeah, you should get 4.7. 0.47, sorry. So 0.47 seconds. That means go from X to Y, back to X, 0.47 seconds. Okay. Okay, next. A to B is 0.2, B back to A another 0.2. So one complete oscillation will be 0.2 plus 0.2, 0.4 seconds. Answer D. X to Y is 1.5. Okay. Just now, for preceding examples or questions, it's always from one extreme end, swing to the other extreme end, back to the extreme end, right? This one, if X is here, you'll swing to Y, back to X, swing to another point, let's call it Z, then back to X again. This is also one complete oscillation. And since X to Y alone, 1/4 of oscillation is 1.5 seconds. 4 is what is correct? Answer 6 seconds. Right? 4 times 1.5. So easy. It takes 13.8 seconds for pendulum to swing from X to Y and back again 20 times. What is the period? So 13.8 divided by 20. So you will get 0.69 seconds. Answer is B. Clear? Up to this point, anybody got questions? No? You any questions? No? Okay. Just now is what is the variation of oscillation and period for one complete oscillation, right? So the swings of a simple pendulum of fixed length are 10 degrees wide, and each complete swing one complete swing is still one complete oscillation, takes 1 second. If the swing is reduced to 5 degrees, how long will each swing take? So before I go through, anybody want to guess what's the answer? Presume same speed. Yes, you can say that. C, 1 second. Correct. All right. Now, for pendulum, the only two things that affect the period will be the length. Okay, fixed length in this case, so length don't change, so the period don't change. So for the first sentence, the tell you the period is 1 second. Even I reduce it to 5 degrees, right? It will still be 1 second. The other thing is G, gravitational field strength. That will also affect the period. Why? Because this formula, I'm not sure if your schools are going to teach you, but I'm sure that O level will not teach, will not be tested. If they do test you on this, they should give you this formula, which is what I'm going to write down. Okay, so your period, you see your period and your length is directly proportional. So the longer it is, the greater is the period. G is inversely proportional to your capital T period. So the greater the G, the shorter the T. Okay? So what this tells us is it's independent of degree of displacement, amplitude of displacement, and the mass of the board itself. Doesn't bigger board will swing faster, smaller board swing slower, or vice versa. It's all dependent on the length of the string. Clear? And it's not direct. Let's say the length doubled, it doesn't mean the period will double. Because you notice it's actually square root of L. Okay? So it's not double. Yes, you increase, but you will not increase proportionally. Next. Okay, weights attached to two successive strings are given small displacement and allowed to swing freely. Their periods of oscillation will be equal if they have the same length of string. Clear? So I'd like to test you on this. So don't be fooled by them. Okay, next will be the open-ended question already. A simple pendulum is set up as shown in the diagram. The ball is then moved to A and then released. What is meant by the periodic time of a simple pendulum? This question is basically asking you for the definition of period. Okay, so if you look at your notes, you look at your textbook, you look at the notes teacher gave you, you look at lessons, they'll tell you period is the time taken for one complete oscillation. How long it takes for not wrong, but for definition questions or where questions they need to give the exact, they give the definition, it has to be exact. So it'd be good to memorize the definition either from your notes or from your textbook. Okay, so sometimes your test, your WA, you'll be test. Certain questions will come out testing you your knowledge of your definitions. As to what will come out is very hard to say. It depends on the person who set the paper. Okay, next. It's time taken for one copy oscillation. The period of the above pendulum 1 meter long is approximately 2 seconds. State clearly how you will determine the period of such as using. Okay, this type is about experiment. So if you do it in your school, what happens is you will let the pendulum swing, okay, for a few times first for it to stabilize. Then you start timing. And you don't just time for one complete oscillation. You time it for 20